Labas, my name is Mangirdas, and today I'll do my best to make your life easier with some Flutter code generation. First of all, I want to set the right expectations for this talk. There are tons and tons of Flutter packages and tools to generate code, but I will only introduce you to some of those that I'm familiar with and that I'm using every day as a Flutter developer. The main goal of this talk is, not to introduce you to every single code generation option, but to provide you some of those. And when you get into the situation when you need some boilerplate or some generated code, you would get that click in your hand and you would know that this tool or this package exists somewhere there in Flutter ecosystem and you could use that. Today we'll try to generate some code for localization, assets, objects and state, and also widgets. Let me briefly introduce myself. So as I mentioned, I'm Mangirdas. I'm a software engineer from Lithuania. I'm also a mobile tech lead at Below, and we are building a Flutter app out there. And I'm also a Google developer expert for Flutter and Dart technologies, and also an organizer at Flutter Lithuania. And I'm still using Flutter for 3 years now, so I think I can share some useful tips with you. To understand the concept of code generation better, we should review the basic development flow. So in the beginning, as usual, you have an idea, you want to implement something, and then you try to transfer this idea to the code, and usually it takes some time. But after that, after writing all the code, you get the idea there and it's actually working, maybe in production, maybe not, that's up to your project. When we look at the same development flow while using the code generation, it's really similar. As usual, again, you have an idea and you want to transfer that idea to your code, but this time you are not writing all the code by yourself, you are just defining some configuration, some metadata, and from that you use various packages and tools to generate the remaining code, so you could use it later in your code base, and actually this code could replace the one that was previously maybe manually typed there, So yeah, after that the ending is the same, the code is working, the app is working, so that's it. So basically code generation just reduces the amount of time needed to implement the same code. And we could start with localizations, and for those who are not familiar with this term, localization is the process of adapting a product or content to a specific language, culture, or location. For this, we'll use the ENTL package, and it's I think the most popular package for localizations. And this package provides some facilities, including message translations, plurals and genders, date number formatting and parsing, and also bidirectional text. So as usual, as adding any other package into your Flutter project, you need to add it to your pubspec.yaml file, and also under the Flutter section in your configuration, you need to define that you'll use the code generation, and actually it adds the code generation or synthetic package support. And for those who are not familiar what the synthetic package is, it's basically a generated package that is generated outside of your project file directory, not in the lib folder, but automatically available to your project. So meaning this package exists outside of your project, but it's automatically important, and you do not need to specify this in your configuration or pubspec YAML file. And also, in addition, for the localizations to work, you need to define the L10N YAML file, or it could be read as lion. And in this file, you need to specify where is your ARB files, and we'll talk about those later. Also, you need to specify what's your template or your base file for localizations, and also you need to define what's the file name of your output. So talking about ARB files, so consider ARB files as JSONs on steroids, or basically a JSON files that are adapted to localizations. So as you could see, the syntax is basically a JSON file, but each localization key is described by a key and its value, and also each of this key has some metadata or some descriptions about this key. So as you could see in the example, the app title has a value, but also it has a metadata about this specific key, which describes where this localization key should be used. And also, if you're translating into several languages, so you specify the same ERB file just with the different locale of your file, and you do not need to provide the metadata over there, you just need to provide the specific localization keys and their translations to that language. And also, when using localizations, I want to access them easier, so I like to add this extension to my code, and later on in the code I do not need to write that I'm using the app localizations of context and then the specific localization key. I could just directly get the L10N access from the context, and as you could see, the code is a lot simpler this way. And now we could see what's the actual generated code from these ERB files. So simple translations or translations with some properties are generated as a simple strings or functions that return strings. So in this case, as you could see, the localization examples title is generated just as a string getter, but the localization that requires some property, it is generated as a function with a parameter. And to be specific, this parameter and its type is defined in the ERB file in the metadata. So you could see that for the placeholders and for the specific locale property, we define its type and its example value. So we could easier track what's the generated code and what's the specific type should be. Also, we could generate date and currencies. So date and currencies, the generated code is really similar to just a generated function using the string parameters. But if the property type is datetime, we see that the specific formatting could be applied to the generated code, and it's the same for currencies. So if we define that the format is currency or simple currency, we could see that the ENTL package adds the specific logic to format the currency in the right way. And also, ERB files are useful for plurals, so meaning if your localization needs a different representation when there's a singular or plural form, which is quite common, or maybe you want to provide one value when the passed key is 0, another value when it's 1, and all the remaining values could represent something different. So this could be also defined using the plurals syntax, which is visible there. And the generated code is basically a mapping between those properties which are passed, and the right properties mapped to the right representation or the right translation of the specific key. So for the usage of localization keys, it's quite common. As I mentioned, I'm using the extension method, which is implemented before. So for the localizations, I'm just accessing those generated functions or those straightforward localization keys, and I'm using those directly in the code. So yeah, if it's a function, you pass parameter to it. If it's just a simple string, you can access it straight away. Okay, so that's about localizations. Now we can move to assets. And what are assets in your app? Basically, that's static files. And that could be fonts, that could be images, that could be icons, that could be JSON files, any other configuration files, you name it. So let's check how to generate them. So for this, we'll use the build runner, which is a build system or tool for Dart code generation. Also, we'll use another package, Flutter Gen, which is the Flutter Code Generation for your assets, fonts, and colors. And it should represent, and by using this tool, you should get rid of all string-based APIs. So as before, if you want to use something, any package in your code, you need to add it to your pubspec.yaml file. So we add under dev dependencies, you could see that we add a build runner and Flutter Gen runner, and these would be used to generate code. But also, since assets and code generation for assets supports some some implementations for other packages. We use we add those to our pubspec.yaml. So those are Flutter, SVG, and Rive, and you would see their usage and why we need to define them there a little bit later. And also when generating static assets, we define we should add those assets to our project, and we use the assets import as a default way, you know, to import assets to your project in Flutter. So basically, under the assets folder, we put all of our static files. You could see there's a colors, there's a flare objects, there are images, icons, JSON files, and so on. And also, in a similar way, we import a custom font. And then in the same pubspec.yaml file, we add another section of the configuration, which is Flutter Gen. And in that Flutter Gen configuration, you define the output directory for your generated code, also the maximum line length of your generated code, whether it's null, safe or not. And our recommendation is to make it true. And also you could see that we define other configurations. And I mentioned previously that the code generation for assets supports the integrations with other packages and tools of Flutter. So for instance, Rive, Flutter, or Flare Flutter. So under the integrations, you set the specific integration to true, and to see the difference, if you do not use those integrations, the generated code would be just a simple path to your static file, and you need to take care of it by yourself. But when you are using the integration, you could see that generated code is a little bit more extended, and instead of just a static path or just a string of that, the SVG gen image in this case is generated, so you could use the image straight away in your code without taking anything else, and you shouldn't care about using those in the code by yourself. So that's really helpful. And to generate assets, you need to use the CLI command, which is flutter pub run build runner build. And yeah, it comes with a build runner package. So you just run this command, and the code is generated under the output folder you defined. And you could see in this example, the code for assets, colors, and fonts are generated. So if we see the assets class is generated, and every single subdirectory is generated as a property of this class, and we could access its properties later on. So for colors, only the static color file is generated. For flare objects, you could see that not only a simple path is generated, but the whole flare gen image, which could be used in the code directly. The same thing is for asset images. Also for JSON files, again, only the static path is generated. And for Rive objects, we could see that also the Rive gen image is generated, meaning that the whole implementation is there, and you just need to use that in your code. As you could see, the colors are defined in an XML file, and the generated code on the right actually generates the specific color. But if you define your colors as material colors, so you generate code for the whole swatch of that, and meaning the whole palette of this single color is generated, and later you could use that in your code, which is really convenient. So for fonts, only a font name is generated, which is not that useful, but as a constant to be used across your app, it's still useful. So if you could see at the generated code, as I mentioned, instead of generating just a single path, the specific code implementation is generated. So instead of writing the image widget and adding the path to it by yourself, you could use the images or SVGs straight away from your assets class. And you could see by using SVGs and images, you could see that on the right they are generated and shown on the UI. For the flare and rive objects, it's really similar. So instead of just generating paths, you could use the generated implementations of those. And also for fonts, as I mentioned, it's not much, just the font family name is generated, so you could use that in your code. And for colors, you saw previously that the XML file defines those colors, and those colors are generated, transferred into specific colors or the whole palette of a single color. So you could use those generated shades or those generated specific colors later on in your code. That's it about static assets. So now we can move on to the objects and state. So first of all, and the first tool we would use for that is Freezed, which is yet another code generation for unions and pattern matching and copy. Also, we'll use the Freezed annotation. In Freezed package, when you use the Freeze package, you need to annotate classes that for this specific classes you need to generate the code. So Freeze annotation is an extension on that package to support you with the remaining tools needed for the specific code generation. And also we use the JSON serializable, which is a really popular package, which basically automatically generates code for converting to and from JSON by annotating Dart classes. So you do not need to manually write code to JSON from JSON, but it is generated for you. Again, if you want to use those packages, you need to add them in your pubspec.yaml file, and you are generating those files in a similar way as assets, but another useful command that could be used is instead of running flutter pub run build runner build, you could replace the last build part to watch, and this command would run in the background. So once you change anything in any watched file which requires code generation, the code generation would be regenerated, and you won't need to run this command manually later on. So there's an example of a freeze class. So you could see that we just create a simple class. We also add the mix-in, which is with whatever is needed for code generation. And instead of defining properties for this class, we define the factory constructor, which properties there represents the final properties that we generated for this class. Also, if you want to generate code for the JSON manipulation to JSON from JSON methods, you add the last part of this class over there. So also, if you're not familiar what the part keywords are, so in Dart as a language, by default, any file is a library, meaning a single file is a separate library. So if you want separate different files to represent the same library using the part keywords, that would basically connect all of those different files into a single library. So that's really useful, and that's needed to generate code for using Freezed. And you could see how the generated code looks like. So first of all, this is the representation of the generated JSON code. So you could see that those provided properties in the factory constructor are used there, and the code for to JSON and from JSON is generated. And this is the remaining code that is generated for the class. So you could see that those parameters passed to the factory constructor are now properties in the class. And also, in addition to that, a lot of other useful methods are implemented. So for instance, the toString method, and you do not need to override it manually. Also, when you are using any state management solution in your app, it's really convenient and really useful to make your states immutable. So before changing the state, you need to check whether the state actually changed. So for this, you need to override the equality operators and hash code and so on. So for this, the Freezed package is also really useful because it overrides those equality operators for you. So you could just use them directly by using those generated classes. And also, you could notice that at the end of those, also the copy with method is generated, which is really useful when you are trying to keep your states immutable. And also the toJSON method, which basically uses the code that was visible in the previous slide. So now we can see about the state management, since I already mentioned that. So in Dart, objects are compared by reference, so two different class instances won't be equal even though the properties in those classes would be the same, you know. So for that reason, there are packages like equatable that resolves the issue by overriding the equality operator for you. That could look similar also, yeah. Using freeze, this code is also generated, so you do not need to use equatable. And by using freeze, also another convenient method is that you define different states of the same class as factory constructors. And though this pattern could be really familiar if you came from, let's say, from the Kotlin background and you are familiar with union classes or seal classes. So actually the idea here is the same. So you'll see later on how this is useful when rendering your UI. So first of all, I'm a fan of block library and Cubits, so I'll just provide a simple example for such state management. If you're not familiar with Cubits, you could see this class as some kind of controller or some kind of business logic needed for your UI. So what this class does is basically it provides the initial state, then on any action, in this case it's load, you set the state that the load is on progress, and then you actually trying to get the categories from some kind of repository, or you are trying to get any other data, and if everything is successful, you change the state to load success. If an error or any exception happens, there you could catch it there and change the state to the load failure. And if you are using this state management solution in your UI, instead of using if-else's in your code, which looks not that nice, you could use the seal classes, or you could use the maybe when, maybe map functions that freeze classes provide. So you could map each state to a specific widget, and it's really useful. The code is very consistent, and also it's shorter than using those if-else-ifs. For instance, you would need to use those ifs and else if you're using the equatable package, but if you're using freezed, you can use the union classes pattern and map your state to dedicated widgets this way. And we can go to the last section, which is widgets. And when talking about widgets, the most straightforward solution to generate them is using, let's say, IDE extensions. And there are various extensions. I just provided you some of those that are really useful and can help you to generate some code. So if you are using awesome Flutter snippets, what you need is basically start typing the short version of a command, and then by pressing tab, the code is generated, and then you just need to fill in the missing gaps, let's say the class name or function names or whatever is provided by this specific snippet. Also, if you're using the Dart data class generator, you could simply write a simple Dart class, and then by using this extension, you could click on generate data class, which generates a lot of code for this specific class. And by looking at this, you could see that this generated code is really similar to what the freeze package generates, and you could start asking why I need to use freeze then. Yeah, it could generate code for you, but later on, if you need to change something, then you would need to go an extra mile to generate such code. So by using freeze, you avoid this, and you just run the same command, and you could keep the code up to date a little bit simpler than using this extension. And also there are some AI powered tools, for instance GitHub Copilot, that the AI looks at your code and could provide you some useful tips, or like IntelliSense provide you how this code could be ended. But maybe at the moment this code is a little bit, or this tool AI in general is a little bit too smart, and sometimes it generates not what you actually need. So also when talking about generating widgets and when you need to actually generate your custom widgets, there's a useful package, or actually the whole tooling system, Mason, and this is a really package in a really early stage, so you should be aware of that. But Mason is basically a Dart template generator that generates code from custom templates that are called bricks. And the main idea behind Mason is really simple. You define different components that are called bricks. That translates to widget units, and later you could use those as a standalone widgets to build bigger structures and bigger widgets. So basically, from those bricks, you are building bigger houses, bigger structures, your code in general. So first of all, let's define the expected result. What want we to generate? So we want to generate like page wrappers in our code, and you could notice some interesting places. So of course, we want to define a custom name for those pages. So maybe that's a home page, maybe that's a profile page, and so on. And also, we want a single section in this page to be optional. So if we provide some kind of flag that we want to generate a route for this page, then we pass this flag, and the code for the routing is generated over there. So that may be convenient. So we'll see how to implement this using Mason. So first of all, we need to define some basic configuration for Mason to use. So by executing Mason init, it creates the base folder for Mason objects with some configuration. And then if you want to create a new brick, you call the Mason new and your brick name command, and it generates a folder under the bricks directory where all your bricks are defined. And by Mason get, it's basically like Flutter pub get. It gets all your configuration, so Mason would know that Mason would know that there is a configuration about this brick, and it would be aware of that. And yeah, inside the Mason configuration, you could see that we define the specific bricks we are using. And if we look at the brick structure, you could see that the name could be dynamic by using the mustache syntax. So it's called like this because of those curly braces. So basically, we define our names. Behind those keywords. So in this case, we have a keyword like snake case, so meaning we'll use the snake casing for the file name. So you could see that the entry point for this keyword starts with the bracket symbol and then with the backslash at the end. And also, if we want to provide as a property and we want to make the file name as a variable, we define the custom properties inside those mustache syntax as well. So in this case, it's name, underslash, and a specific package. Just be sure that when you try to create such file, it is while the file system, it is split into directory and into the file, as you could see on the right, which is not exactly the same as you could see mentioned there in the slides. So yeah, just be aware of that, but the whole configuration is defined the right way. And also inside brick, we are using the same mustache syntax, and also we define the specific keywords that needs to be used there. So for instance, the class names in Dart needs to use the Pascal case and not the snake case anymore. So we define this Pascal case keyword, and also we define the name for our class. So you could see that we use the same name property over there. And also, as I mentioned previously, we need some kind of flag to define that a specific section should be generated or not. So we call this flag routable. And if it's true, the section between these routable keywords would be generated. If not, this specific section would be skipped and the code won't be generated there. There in this class. And also you could see that we have these keywords throughout the whole class, but as you could see, the remaining code is repetitive, so we could skip to the next slide. And we could see that to generate code, we need to execute the specific Mason make the specific brick name command. So basically this command, when running this command, you define the output of your generated code. And also when running this command, if you need any custom properties, Mason would ask you to fill in those. So for instance, in our case, for the name, we just provide custom, and for the flag routable, we could provide either true or false. And if this configuration passes and everything is okay, the generated file is put into your output directory. And if you could see at the generated code is really identical to what we expected, just where the flag keyword was in those places in the file. You could see that the spaces are still left over there, but Dart formatting would pretty much automatically resolve this. So basically the generated code is identical to what we expected. So for custom widgets, if you have a specific template defined, you could generate this code anywhere in your app. So that's really useful. And also, again, Mason is in very early stage, so if you want to make something really complicated, maybe you won't find that already there in the package, but Felix, the author of this package, is working really hard to improve Mason, and just stay tuned and check how this package evolves over time. And that's actually it about this presentation. So if you want to see all the code examples that were provided there in those slides, you could check them in the GitHub page. And these are the official resources from the document, from the docs about the packages I used for those slides. And yeah, save trees, stay solid. Thanks for spending the last 30 minutes with me and Flutter Code Generation. See you.